Hello everyone. We learned in the past how to solve a linear system by substitution method, elimination method. However, in this video we will learn how to solve a linear system by using an inverse matrix method. And we are going to be focusing on the 2 by 2 matrix. What does that mean? If I have a matrix A is 1, 2, 3, 5, 0, 7, I can say that this matrix has 2 rows and 3 columns. So I can say that A basically is a 2 by 3 matrix in which the first number represents the number of rows, the second number represents the number of columns. So it's 2 by 3 matrix, and it's not 6, okay? You need to keep it as 2 by 3. Now, let's say that number 1 here, what does number 1 represent? Number 1 position is basically can be represented as A11. What does that mean? The first number is the number of row, the second one is the number of columns. So the number 1, the element 1 is basically in row 1, column 1. What about 2? 2 is basically the position of the element 2 is in the first row, second column. 3 is in the first row, third column. 5 in the second row, first column. 0, second row, second column. And finally 7, second row, a third column. Okay, so each one of these is called an element. Now what about if I have a 2 by 2 matrix? Well, if I have a 2 by 2 matrix like, let's say 1, 7, 0, 9, so this is going to be A11, A12, first row, second column, A21, second row, first column, A22, second row, second column. In order to solve a linear system by using the inverse matrix method, we need to find first the inverse. And to find the inverse, there is a formula here. A inverse equal to 1 over this kind of absolute value. It's not absolute value, it's called a determinant. And we can use a determinant A or determinant A. And determinant A basically comes from multiplying A and D minus the multiplication of B and C. So the product between A and D minus the product of B and C. If you found the determinant, then you will multiply 1 over the determinant, multiply a new matrix. What is then the new matrix? It's basically came from changing the positions between A and D. So D is going to come here and A is going to come there, and only changing the signs between C and B, no switching the positions. So let's try to find the inverse here. What is the inverse of A? Well, first I need to find the determinant. That's going to be equal 3 multiply 2 minus 1 multiply 4. Okay, that's going to be equal 6 minus 4, which is 2. Now what is A inverse? It's going to be 1 over the determinant multiplied by the new matrix. You switch between these two spots and only you change the sign of 4 and 1. And then you will multiply each element by this constant, which is 1 over the determinant. And that's going to be equal to 2 multiply 1/2 is 1, negative 1/2, negative 4 times 1/2 is negative 2, and 3 over 2. So that's my inverse. Let's try this one here. So the determinant is equal to 3 by 3 minus 0 by negative 5. Well, 9 minus 0 is 9. Now the inverse, 1 over the determinant multiplied by, now it's time to switch between these two. They are already the same thing. and then change the signs of these two. 0 is 0, -5 will be 5. And then you write the final answer by multiplying these. 3 times 1 over 9 is 1 over 3. 0 times 1 over 9 is 0. 5 over 9. And 3 times 1 over 9 is 1/3. Let's try to find the inverse here. So the determinant, 6 by 2 minus 4 by 3. 12 minus 12, which is equal to 0. So if you try to find the inverse, you will say 1 over 0 multiply the new matrix. Now you cannot divide by 0. So what does that mean? There's no inverse. So B is considered as singular matrix. Singular matrix, that's a matrix that the determinant equal to 0. Now we learned how to find the inverse. Now we are going to put these things together in order to find the solution for the linear system. So if I have -3x plus 4y equal 5, 2x minus y equal -10, I need to find the solution for this linear system. Now, what does it mean to find a solution for a linear system? If I try to draw any linear system, I'm going to get three different scenarios. I could have a first line crossing the second line. They are intersecting at one point, and this point is going to be my solution. It's point of intersection. That's my solution. So the solution of a linear system is when the two lines intersect at one point, of course. Sometimes these lines will never intersect. That's when I have two parallel lines. These lines will never intersect, so there's no solution. Okay? Finally, I might have a line, and then the second line basically overlapped, so they end up the same thing. So then I will have an infinite number of solutions. Okay? So you have two scenarios: no solution when they are parallel, infinite number of solutions when you end up with the same line, and one solution when two lines intersect at one point, and this point is going to be your solution. So now you can solve it by using substitution method, elimination method. However, we need to solve it by using the matrix method and the inverse matrix method in particular. So in order to do that, we need to create a matrix. So we are going to create three matrices here. The first one is going to be my coefficient matrix. Coefficient matrix, I need to look at the coefficients. This is a coefficient. This is a coefficient, and the coefficient here is -1. Coefficients are the numbers attached to the variable. So in this case, I have -3 and 4 for the first equation. The second one, 2 and -1. These are considered x's. These are y coefficients. And then, so this is my coefficients matrix. Second, I need to create the variable matrix. And variable matrix basically is how many variables do I have? I have x and I have y. Finally, I will create the constant matrix. Constants are the constant numbers that has no variable attached to them. In this case, I have 5 and -10. So now I have three matrices here. I have coefficient matrix, variable matrix, and the constants matrix. Now, you need to know something about multiplying, and there's a multiplication here for sure. You need to learn something about multiplying matrices. If I have a matrix in a size 2 by 3, and I want to multiply it by another matrix, okay, and I need to find the result, I can only multiply it by a matrix that starts with the rows same as the number of columns in A. So if the number of columns in A is 3, then B should start with this number, 3 rows. So if A is 2 by 3 matrix, then B should be 3 times anything. It could be 1, it could be 2, it could be 5. The result matrix will be 2 by 5 matrix. So let's look at this case here. I have a 2 by 2 matrix. I have to start with 2. Do I have 2 rows? Yes. How many columns? 1. So these 2 will cross. The result matrix should be 2 by 1. Is it 2 by 1? Yes, 2 rows and 1 column. Okay? So you need to know this about what matrices can be multiplied. Okay? Now, so I found already the matrices. Now the next step will be, I'm going to call the coefficient matrix A. I will find the inverse of this matrix. So I need to find the determinant first, which is -3 by -1 minus 2 by 4. And that's going to be 3 minus 8, which is going to be -5, right? And now, next I'm going to find the inverse, which is 1 over -5, which is -1 over 5, multiply the matrix A after you switch between these two and the sign of 4 and 2. It's going to be -1, -3, -4, and -2. And then you find the answer. 1 over 5, 4 over 5, 2 over 5, and 3 over 5. That's my inverse matrix. So now I'm going to multiply this matrix by the constant matrix, which is 5 and -10. And when you multiply them, this is how you multiply. You multiply the first row with the column, and then second row with the column. Okay, so let's do that. And remember, you are going to end up with a 2 by 1 matrix. That's going to be equal to, first row with the column is going to be 1 over 5 times 5. Okay, plus, now 4 over 5 times -10. Same with the second. Then next will be this multiply 5, and then this multiply the -10. So will be 2 over 5 multiply 5 plus 3 over 5 multiply -10. And that's going to be equal to, this is 1, and this is going to be -8. That's going to be -7. And here will be 2, and that's going to be -6. That's going to be -4. So now these are basically x and y. So now your solution is going to be the ordered pairs -7 and -4. It's x comma y. That's my solution. In order to check your solution, you can substitute x by -7, y by -4 in each equation in order to see whether this point will satisfy the system. Let's try this question here again. We're going to follow the same steps. First, we need to create A, and A will be actually your coefficients. So 1, the coefficient here is 1, 4, 2, and -1. Find the determinant to find the inverse. 1 by -1 minus 2 by 4. And then you will multiply here. That's going to be -1 minus 8 is -9. Okay, And now you will find the inverse, which is going to be A inverse negative 1 over 9 multiply, you switch between these two and the sign here, and then you find the 1 over 9, 2 over 9, 4 over 9, and negative 1 over 9. And then you take this matrix, the inverse matrix, multiply it by the constant matrix. Constant matrix is 6 and 5. And then you find the answer. So you multiply 1 over 9 times 6 plus 2 over 9 times 5. Same here, 4 over 9 times 6 plus negative 1 over 9 times 5. And final answer will be 16 over 9 and 19 over 9. So what is x and y? X is going to be 16 over 9, y is going to be 19 over 9. So your point of intersection or your solution is 16 over 9 comma 19 over 9. Okay, finally one more question here. So A, we need to find A, the coefficient matrix 5, 2, negative 3 and 5. And now the determinant, you will multiply these two, and that's basically going to be equal to 31. And then you will say A inverse 1 over 31 multiply the new matrix, which is 5. Again, you switch the sign here. And then you will multiply this matrix by the constant matrix, which is 1 and 19. And that's going to be equal to 5 over 31 multiply 1 plus 3 over 31 multiply 19. Negative 2 over 31 multiply 1 plus 5 over 31 multiply 19. And the final answer is going to be equal to 2 and 3. So now your solution or point of intersection will be 2, 3. So that's everything for today's lesson, guys. Please let me know if you have any question, and see you in the next video. Bye bye.